In the previous class, we studied polynomial functions. Since it becomes challenging with functions of degree 4 or higher, today, we'll focus on linear, quadratic, and cubic functions. Let's explore any patterns in the given points. Starting with the first three. The increase in x values is 3, followed by 8. Correspondingly, the increase in y values is 6, then 16. Calculating the ratio of y increase to x increase, we get 6 over 3 and 16 over 8, both equal to 2. Thus, the slope is 2, indicating a linear function, using the point-slope form of a linear function for convenience. Substitute 1 for x1 and 1 for y1. We derive the equation y equals 2x minus 1. A graph would provide a clearer understanding. Now, onto the second set of points. The x increase is 3, followed by 4. The corresponding y increase is -9, then 16. Calculating the slope as before, we find it doesn't match a linear function. Therefore, it seems unlikely to be a linear function, as confirmed by plotting the points. Assuming a quadratic function, we substitute the points into the standard form of quadratic function. For the first point, -1, 7. Substitute -1 for x and 7 for y. For the second point, substitute 2 for x and -2 for y. And for the third point, substitute 6 for x and 14 for y. Organizing the equations, we form a system of equations with variables a, b, and c. To simplify, we label the equations 1, 2, and 3. First, subtract 1 from 2. Then divide by 3, and designate it as equation 4. Second, subtract 2 from 3. Divide by 4, and designate it as equation 5. Lastly, subtract 4 from 5, side by side, and solve for a. Yielding a is 1. Substituting 1 into equation 4 gives b is -4. Substituting a and b into equation 1 gives c is 2. Therefore, the quadratic function we seek is found. A graph would confirm that it is a parabola passing through the given 3 points. Now, onto the third case with 4 points. As there are 4 points, plotting them on a graph suggests that the function is neither a straight line nor a parabola. Assuming it to be a cubic function, let's substitute the given points into the standard form of cubic function. The point 0, 6 implies the y-intercept. And upon substitution, we easily find that the constant term, d, is 6. Now, we substitute the values of the remaining 3 points into the equation. Organizing the equations, we form a system of equations with variables a, b, and c. To simplify calculations, we label the equations 1, 2, and 3. First, add equations 1 and 2 to easily find the value of b, which turns out to be 1. Substituting b into equation 2, we derive an equation for a and c, labeling it as equation 4. Similarly, substituting b into equation 3, we derive another equation for a and c, labeling it as equation 5. Simplify the coefficients in equation 5, and subtract equation 4 from equation 5. Calculate these side by side. 3a equals 6. Yielding a is 2. Substituting 2 into the equation derived from equation 4, we find the value of c Now, we have found all 4 unknowns we sought. Therefore, the cubic function we are looking for is found. A graph would confirm that it is a cubic curve passing through the given 4 points. See you next time.